In this video on leaning rod, we have a uniform plank of weight 100 newtons. So do note that they've given us weight rather than mass. Since it's uniform, the weight will be acting down the middle. So halfway along the 4 meters, so we can put something like this. So it'll just be 100 rather than 100 G. And then we can decompose in this fashion. We know here that the angle here will be the same as the angle there, therefore alpha. Next, we're told that it is on rough horizontal ground. Again, rough tells us that we should expect friction. So we have friction, and then we have normal contact force at A. We're going to call that RA. This is not in limiting equilibrium, so we know that friction is going to be, by formula, less than or equal to mu times RA. We're also told that the ladder is resting against a drum, so we're going to have a normal contact force. I'm going to label that RC. I'm going to decompose RC, and so we're going to have a component that is parallel to the vertical axis and then parallel to the horizontal axis. So here, this bit right here will be alpha. That will be 90 minus alpha, and therefore here will also be alpha. So right here will be RC cos alpha, and then here will be RC sine alpha. In the question, they tell us that sine alpha is 1/3. We can quickly draw a right angle triangle. So alpha sine is opposite over hypotenuse, therefore this is going to be root of 9 minus 1, which is root 8. So cos alpha will be root 8 over 3. We know sine alpha already to be 1 over 3. Okay, so in this question, they want us to find the least possible value of mu. So we have done the first step for this type of problem, which is a detailed force diagram. Second step is to resolve vertically. So the upward forces sum and equal to the downward forces. So that means that RA is equal to 100, this 100, and then we have another upward force, which is RC cos alpha. So that would be 100 minus RC cos alpha. Cos alpha, of course, is root 8 over 3. So in other words, RA plus root 8 over 3 RC is equal to 100. So the up forces sum and equal to the down force. Next step will be to resolve horizontally. So the forces acting to the right sum and equal to the forces acting to the left. So here we have friction. So friction is equal to RC sine alpha. We know sine alpha is 1/3. So this will be 1/3 RC. And that will be equation number 2. We can call that equation number 1. The final step is to take moments about the point A. A, of course, is where the ladder, or the plank in this case, meets the ground. So when we're taking moments, it's going to be distance from the pivot point A times by the perpendicular component of the force. So because that's a uniform plank, this point here will be halfway along the 4 meters. So that would be 2 times the perpendicular component of 100 will be 100 cos alpha. So 100 cos alpha is root 8 over 3. And then the other bit will be, so this will be the clockwise turning effect. That will perfectly match the anti-clockwise turning effect, which will be 3 times RC. So because the plank is in equilibrium, we know that the clockwise turning effect will be the same as the anti-clockwise turning effect. So that will be equation 3. From equation 3, we can solve for RC. So RC will be 200 root 8 over 3 divided by 3. So here, when we type that into the calculator, we're looking for 200 root 8 over 9, and that will give us 200 root 8 divided by 9. So RC is going to be approximately equal to 62.9 to 3 SF. And we'll try to use the calculator value as long as possible. So given that we now know what RC is, we can, so using equation 1, we can work out RA. So RA will equal to 100 minus root 8 over 3 times 62.9. And then we'll plug in the calculator value right there. So we'll have 100 minus root 8 over 3, and then times by 62.9, or the calculator expression, and that will give us approximately 40.7, again to 3 significant figures. So what we have then is that friction, which is 1/3 RC, will be smaller than or equal to mu times RA. So we'll have 1/3 RC, which is going to be 62.9, is going to be smaller than or equal to mu times RA, and RA is 40.7. Rearranging that then, mu will be greater than or equal to 62.9 divided by 3 over 40.7. So 62.9 divided by 3 and then divided by 40.7. So here mu will be greater than or equal to 0.52 to 2 significant figures. So mu, the lowest value therefore for mu is going to be approximately 0.52. So I've done some rounding at the very end, so that might affect the accuracy, the final accuracy, but that should be fine. And then that will be 2 significant figures.